Welding Metallurgy and Inspection. Hello folks, welcome to the course on Welding Metallurgy and Inspection. This lesson will delve into the fundamental principles of welding metallurgy, material science, inspection methods, and defect recognition and repair techniques. This course is designed for employees in the engineering and manufacturing sectors, particularly those involved in welding operations. By the end of this lesson, you will have a comprehensive understanding of how to ensure the integrity and quality of welded structures. Welding metallurgy and material science. Welding metallurgy is the study of how welding affects the microstructure and properties of metals. It combines principles of metallurgical science with the practical aspects of welding technology. Key areas of focus include 1. The microstructure of metals. Crystalline structure metals have an organized atomic structure forming crystals. Welding can alter these structures, affecting the metal's strength and durability. Grain boundaries, the regions between crystals and metals, which can be affected by heat during welding. Changes to grain boundaries can impact mechanical properties. 2. Thermal cycles and their effects. Heat-affected zones has the area of metal that is not melted but has undergone structural changes due to the high temperatures during welding. Phase transformations, heating and cooling cycles can cause phases to transform within the metal, affecting its characteristics. 3. Alloying and its importance. Role of alloying elements. Elements such as carbon, manganese, and chromium affect the weldability and final properties of alloys. Prevention of hot cracking. Proper selection and control of alloy compositions can minimize cracking during solidification. Weld inspection and testing methods. Inspection and testing of welds are critical to ensure safety and performance. Various non-destructive and destructive testing methods are employed. 1. Non-destructive testing and DT methods. Visual inspection, the simplest form of inspection involving examination of surface features. Ultrasonic testing uses high-frequency sound waves to detect internal flaws. Radiographic testing involves X-rays or gamma rays to examine internal defects. Magnetic particle testing detects surface and near-surface discontinuities in ferromagnetic materials. Liquid penetrant testing reveals surface-breaking defects by using a liquid with high penetrability. 2. Destructive testing methods. Tensile testing determines the strength of the weld by pulling it until failure. Impact testing measures toughness by applying a sudden load. Bend testing assesses ductility and soundness of the weld. Defect recognition and repair techniques. Recognizing and repairing weld defects is crucial to maintaining weld integrity. Here are common defects and repair strategies. Common weld defects. Porosity, gas pockets or voids trapped in the weld, often caused by contaminants. Cracks can occur during cooling due to stress concentrations. Inclusions, foreign materials and trapped in the weld. Undercut, grooves formed at the toe of the weld. 2. Repair techniques. Grinding, used to remove surface defects before re-welding. Re-welding restores welds with additional passes to improve integrity. Post-weld heat treatment (PWHT) applied to reduce residual stresses and improve toughness. Executive summary. Here's a summary of welding metallurgy and inspection. Welding metallurgy. Welding metallurgy is the study of the physical and chemical changes that occur in metals during the welding process. Understanding welding metallurgy is crucial to producing high-quality welds. Key concepts. 1. Thermal cycles. The heating and cooling cycles that occur during welding can affect the microstructure and properties of the metal. 2. Phase transformations. The heating and cooling cycles can cause phase transformations, such as the formation of austenite or MARTENSITE. 3. Microstructural changes. The welding process can cause changes in the microstructure of the metal, including grain growth, recrystallization, and precipitation hardening. 4. Residual stresses. The welding process can cause residual stresses in the metal, which can affect its properties and behavior. Welding inspection. Welding inspection is the process of examining welds to ensure they meet the required standards. Types of inspection. 1. Visual inspection, a visual examination of the weld to check for defects such as cracks, porosity, or lack of fusion. 2. Radiographic inspection, the use of X-rays or gamma rays to examine the internal structure of the weld. 3. Ultrasonic inspection, the use of high-frequency sound waves to examine the internal structure of the weld. 4. Magnetic particle inspection, the use of magnetic particles to detect defects in ferromagnetic materials. Inspection techniques. 1. Destructive testing, the use of destructive tests such as tensile testing or bend testing to evaluate the properties of the weld. 2. Non-destructive testing, the use of non-destructive tests such as radiography or ultrasonic testing to evaluate the properties of the weld. 3. Surface inspection, the use of surface inspection techniques such as visual inspection or magnetic particle inspection to evaluate the surface quality of the weld. Importance of welding metallurgy and inspection. Understanding welding metallurgy and inspection is crucial to producing high-quality welds that meet the required standards. It helps to 1. Ensure safety. By ensuring that welds are free from defects and meet the required standards, welding metallurgy and inspection help to ensure the safety of people and equipment. 2. Improve quality. Welding metallurgy and inspection help to improve the quality of welds by identifying defects and imperfections. 3. Reduce costs. By identifying defects and imperfections early on, welding metallurgy and inspection can help to reduce costs by minimizing the need for repairs and rework. 4. Increase efficiency. Welding metallurgy and inspection can help to increase efficiency by optimizing welding processes and reducing the need for unnecessary inspections. Here's a summary of welding metallurgy and material science. Welding metallurgy. Welding metallurgy is the study of the physical and chemical changes that occur in metals during the welding process. Key concepts. 1. Thermal cycles. The heating and cooling cycles that occur during welding can affect the microstructure and properties of the metal. 2. Phase transformations. The heating and cooling cycles can cause phase transformations, such as the formation of austenite or martensite. 3. Microstructural changes. The welding process can cause changes in the microstructure of the metal, including grain growth, recrystallization, and precipitation hardening. 4. Residual stresses. The welding process can cause residual stresses in the metal, which can affect its properties and behavior. Material science. Material science is the study of the properties and behavior of materials, including metals, ceramics, and polymers. Key concepts. 1. Crystal structure. The arrangement of atoms within a material can affect its properties and behavior. 2. Phase diagrams. Phase diagrams show the equilibrium phases present in a material as a function of temperature and composition. 3. Thermodynamics. Thermodynamics describes the relationships between heat, temperature, and energy in materials. 4. Kinetics. Kinetics describes the rates of chemical reactions and phase transformations in materials. Relationship between welding metallurgy and material science. Welding metallurgy and material science are closely related fields that together provide a comprehensive understanding of the physical and chemical changes that occur in metals during the welding process. Applications. 1. Welding process development. Understanding the relationships between welding parameters, material properties, and weld microstructure is essential for developing optimized welding processes. 2. Weldability testing. Weldability testing involves evaluating the suitability of a material for welding based on its composition, microstructure, and properties. 3. Weld inspection and testing. Understanding the relationships between weld microstructure, properties, and performance is essential for inspecting and testing welds. 4. Materials selection. Understanding the properties and behavior of materials is essential for selecting the optimal material for a particular application. Here's a summary of weld inspection and testing methods. Visual inspection. 1. Visual examination. A visual examination of the weld to check for defects such as cracks, porosity, or lack of fusion. 2. Dimensional inspection. A dimensional inspection to check the weld's size, shape, and location. Non-destructive testing and DT methods. 1. Radiography X-ray or gamma ray uses X-rays or gamma rays to examine the internal structure of the weld. 2. Ultrasonic testing uses high-frequency sound waves to examine the internal structure of the weld. 3. Magnetic particle inspection uses magnetic particles to detect defects in ferromagnetic materials. 4. Liquid penetrant inspection uses a liquid penetrant to detect surface defects. 5. Eddy current inspection uses an electromagnetic field to detect defects in conductive materials. Destructive testing methods. 1. Tensile testing tests the weld's tensile strength by applying a tensile load until failure. 2. Bend testing tests the weld's ductility by bending the weld until failure. 3. Impact testing tests the weld's toughness by applying an impact load until failure. 4. Macro etching exposes the weld's microstructure by etching the surface.
Other testing methods. 1. Leak testing tests the weld's integrity by applying a pressure test. 2. Acoustic emission testing detects high-frequency acoustic emissions generated by defects or cracking. 3. Phased array ultrasonic testing uses a phased array probe to inspect complex geometries. Importance of weld inspection and testing. 1. Ensure safety. Weld inspection and testing ensure the safety of people and equipment. 2. Improves quality. Weld inspection and testing improve the quality of welds by detecting defects and imperfections. 3. Reduces costs. Weld inspection and testing reduce costs by minimizing the need for repairs and rework. 4. Increases efficiency. Weld inspection and testing increase efficiency by optimizing welding processes and reducing the need for unnecessary inspections. Here's a summary of defect recognition and repair techniques. Defect recognition. 1. Visual inspection. Visual examination of the weld to identify surface defects such as cracks, porosity, or lack of fusion. 2. Radiography uses X-rays or gamma rays to detect internal defects such as porosity, lack of fusion, or cracks. 3. Ultrasonic testing uses high-frequency sound waves to detect internal defects such as cracks, porosity, or lack of fusion. 4. Magnetic particle inspection uses magnetic particles to detect surface and near-surface defects in ferromagnetic materials. Common weld defects. 1. Porosity. Small holes or voids in the weld metal. 2. Lack of fusion. Incomplete melting of the base metal or filler metal. 3. Cracks. Fractures in the weld metal or heat-affected zone. 4. Slag inclusions. Entrapped slag particles in the weld metal. 5. Undercut. A groove or depression at the toe of the weld.
Repair techniques. 1. Grinding. Removing defects or excess weld metal using a grinder. 2. Chipping. Removing defects or excess weld metal using a chipping hammer. 3. Weld repair. Depositing new weld metal to repair defects or damaged areas. 4. Heat treatment. Applying heat to relieve residual stresses or restore material properties. 5. Re-welding. Completely re-welding a joint to replace a defective weld. Best practices for defect recognition and repair. 1. Regular inspection. Regularly inspect welds to detect defects early. 2. Proper training. Ensure personnel are properly trained to recognize and repair defects. 3. Use of proper equipment. Use proper equipment and tools to repair defects. 4. Documentation. Document defects and repairs to maintain a record of weld quality. 5. Continuous improvement. Continuously improve defect recognition and repair techniques through training and process improvements. Conclusion: understanding welding metallurgy, utilizing effective inspection methods, and mastering defect recognition and repair are essential for ensuring the quality and safety of welded structures. Continuous learning and adherence to best practices in welding processes contribute significantly to successful outcomes in engineering and manufacturing environments. We hope this lesson has enhanced your understanding of welding metallurgy and inspection methodologies. Thank you for participating, and we encourage you to apply these principles in your daily operations. Happy welding and learning! See you again in the next lesson.